Hi, boys and girls. This is part 2 of lesson 2.4, equations with variables on both sides. In the first part of 2.4, we discovered that there are equations where there's a variable on both sides, and we learned how to get all the variables on one side and then solve for the variable. Well, here's the thing. When you have equations with variables on both sides, sometimes weird things can happen, all right? So, this section of the lesson is going to talk about the weird things that can happen, all right? Sometimes we have equations that have one solution, and those are the kind that you're familiar with. Those are the kind you've been solving for years. You get down to the end and it's x equals 1 or x equals 0. It has one solution, but sometimes things get weird. Sometimes an equation has no solution, all right? And sometimes any number will work for x. It will have infinite solutions, okay? So I want to show you examples of what that's going to look like for you. All right, this guy right here, this is an example of what we're familiar with, okay? You can solve this for x, all right? There are two different amounts of x on the left and the right-hand side. It could be solved. I don't know that I really want to try solving it because I just made it up. But what you would do here is you would subtract 2x from both sides, and then you have 5 equals x minus 1. You add 1 to both sides, and you get one solution. X is a very ugly 6. Yes, very, very ugly 6. All right. That's one solution. Okay? That's the kind of equation that we have always solved. One solution, and we're used to that. Keep in mind that x equals 0 is still a solution. Here's the weirdies. Look at this next one here. This one's inherently flawed. No matter what we make x, we're going to multiply the same number times 5 on both sides, but then on this side, we're always going to subtract 3. So the left side is always going to be 3 less than the right side. This will never work. There's never going to be a value for x that is going to give you the same amount on this side as this side. All right? This equation has no solutions. If we were to try to solve it, what would it look like? Well, if I were to try to solve this one, maybe I didn't notice it, I would say, well, I want to get all my variables on one side. I want to pick the smaller one, but there isn't a smaller one. All right, they're both the same. So what if I just subtract 5x from both sides? Well, then what I get is negative 3 equals 0. Negative 3 doesn't equal 0. It's impossible. There's no solution for this equation. Let me clean that up and give it its label. No solution. If the variables on each side are equal, but the other stuff that's going on is not, there's no solution. What about this equation? What would work for x? What about 1? If I made x 1, would it work? Would it be equal on both sides? This would be 3 times 1 is 3 plus 1 is 4. This would be 3 times 1 is 3 plus 1 is 4. 4 equals 4. Okay, 1 worked. How about 2? Would 2 work? What about 3? What about 427? It doesn't matter what number I pick for x. I did the same thing to x on this side as I did on this side. This is called an identity. It has infinite solutions. X can literally be any number, and it still works, okay? You'll know an identity when you look at your equation and the left and the right sides are identical. Think about identities are identical. So let's look at some examples. Okay, here's example 6. It's on page 96. This one, when you first look at this equation, you can't tell if the left and right sides are identical. You have to simplify it. So the first thing we did was they used the distributive property. And they said 6 times y is 6y, and 6 times negative 5, I need my pen, 6 times negative 5 is negative 30, 2 times 10 is 20, and 2 times positive 3y is positive 6y. 6y here, 6y here. But notice we've got minus 30 here. So we're subtracting 30 from that 6y and adding 20 to that 6y. This is not smelling kosher to me. So what we do then is we want to get rid of the smaller variable. Well, okay, if we did that, neither one is the smaller one. They're the same. So if we subtract 6y from both sides, which is what they've done here, you end up with negative 30 equals 20. Negative 30 doesn't equal 20. So this is negative 30 does not equal 20. So this equation has no solutions. If you end up with a false statement, your equation has no solutions. Now, what about this guy? Again, when you originally look at the problem, you can't tell if the left and right side are the same. You need to do some simplifying. So that's what we're going to do. We have 7x over here, and then we're going to distribute this plus 5. That's going to give us plus 5x. And 5 times negative 1 is negative 5. Now maybe we combine some like terms here. Clean this up a little bit. 7x plus 5x is 12x minus 5. And about now we were thinking, you know what, let's get all of our variables on one side. But when I look at the left side and I look at the right side, I go, you know what, these are identical. And they are. So this is actually an identity. Any number will work for x. X can be any number. They're saying they subtracted 12x minus 5 from each side. I wouldn't even have done that. I would have done them one at a time. I would have subtracted 12x from both sides and gotten negative 5 equals negative 5. Still a true statement. So this equation is an identity which is never going to fit in that space. The way I'm writing this identity, it is true for all values of x. So you've met the weirdies of the math world. Equations that have no solutions and equations that have infinite solutions. This check is on page 96, and they're asking you to determine if each of these equations has one solution, no solutions, or infinite solutions, aka identity. So here I've typed them out because I wanted to be able to solve them. All right, A, we distribute 8 times G is 8G. All right. 8 times 6 is 48 equals 5G plus 3 times G is 3G and 3 times 16 is 48. Mental math. I see an opportunity to combine like terms. These two G terms are on the same side of the equal sign, so they can be added together. That gives me 8G plus 48 on the left, and those add to 8G plus 48 on the right. And when we have identical sides, we have an identity, and it has infinite solutions. All right, which brings us to B. There's nothing I can do on this left right now. I need to get rid of these parentheses. So I'll just bring the left side down. 3 times 5x is 15x. 3 times negative 4 is negative 12. Minus 10x. Still not a whole lot I can do on this left. I'm still cleaning up the right side. I have a 15x and a negative 10x, which will give me a positive 5x minus 12. Now you see what we have here. We have 5x on both sides, but on this side we're adding 5, and on this side we're subtracting 12. There's no value of x that will make this true. If you still don't believe me, go ahead and subtract 5x from both sides, and you get a false statement. 5 equals negative 12. Because that's a false statement, this has no solution. Very hard to write with this pen. I do have a new pen that I've heard is better, so I'm excited to try that, but I haven't had a chance to install it yet. Okay, C. Oh, this looks pretty straightforward. We want to get all our variables on one side, right? So let's get rid of the smaller one first. We'll subtract 3w from both sides. I get 2 equals 4w. Divide both sides by 4. Excuse me. And I get w equals 1/2. That is one solution. And that brings us to our last example, D. Let's clean it up a little bit. 3 times 2b is 6b. 3 times negative 1 is negative 3. Minus 7 equals 6b minus 10. Well, combine these like terms. A minus 3 and a minus 7 gives us minus 10. Or you can think of it as a negative 3 and a negative 7 combined to give you a negative 10. Equals 6b minus 10. Look at there. They are identical. And because they're identical, that forms an identity, which means there are infinite solutions to that one. All right. So these are the practice problems. We're going to do these in class. I'm going to have you watch the videos on your own, take the notes, and then in class during Zoom, we're going to do these examples. So make sure you bring your books to class. And if you have any questions, you can ask me then. All right. Have a good day, and I'll see you tomorrow.